So this is doing a numerical limit approximation. So you're going to very soon have tools which will allow you to circumvent this entirely, but this is instructive, so we do this. Right, so what we're going to do is we're going to evaluate this function here at all those different points that are requested and see if we can guess where this thing is going. And it says use 6 digits just because you don't want to lose what you're doing. So we type in e to the power of 5 times t. So it's going to be, in this case, minus 2.5. I'm going to subtract 1. And then I'm going to divide by t. .8358. And it says use at least 6 decimals. 3. Oh. Okay, and let's do it again, only with a different value. E to the power of, okay, 5 times t is minus 0.5. And I'm going to subtract 1. And I'm going to divide by negative 0.1. And I get 3,934. 6934. That's probably good enough. Right, let's do it again. And we're going to get, you know what, I'm going to pause the video and calculate these without your help, without making you watch all this. Okay, see, actually, I went to Wolfram Alpha. I have the app on my iPad. That makes this much faster. So if it's an exam, too bad, you have to click it all in yourself, but if you're working on a homework or something and you want to, you can get Wolfram Alpha to evaluate these things for you, and that's how you do it. If you go to the website or download the app, this is what you would type in. If you didn't type this stuff in, it could just give you a plot, and if you did something like this, I think if you just go like t is equal to 0.10 or something like that, in that case it would give you a plot. So you can experiment with that. It's free. The app is not free, but it's cheap. Right, so anyway, the limit is actually 5. But you don't know that yet. So you would just say limit is probably 5 because that's where it looks like it's zooming in. Interesting though, you should notice that this, even though we're zooming in on 5, we're much slower getting there. Once we get to 5, we zoom off. Exponentials work that way. Alright, so we're going to do the same thing for the next exercise, and I will just do a little prelude first, and then I'll go off and do that again. Okay, so one thing I'm noticing here is that the top factors, and I would love to see if the bottom factors. I'm hoping this will factor something like this. Will it factor? I don't know. Aha, it looks like it does. So I'm never going to put t at -1 exactly. So, and I'm never going to put t at 2. If I were going to put t at 2, then this would be invalid. Okay. So, but neither of those, we're not going to plug in 2, we're not going to plug in -1. So we just have t over t plus 1. It just makes our lives a little easier. Okay. Same kind of thing, except not. Okay, so what's happening is it looks like we have, as we approach -1, it looks like, it looks like we're going down and down. Well, the wrong direction. We're going up and up. It kind of looks like 1 over x, but flipped and shifted. Huh. well, that's what we get. And so the answer is limit does not exist. That's all you gotta do. That's perfect. I mean, I'm unhappy because I think this is, I would like to do better than this for you. Let's see, the asymptote is at 1, and other things I can tell you. I wouldn't expect you to do it on an exam though. So for example, t plus 1 minus 1 is just t, right? And so you can just say 1 minus 1 over t plus 1, and then it's really obvious what's going on. It's the 1 over t graph that's been shifted, flipped upside down and then shifted. So then it confirms what we thought was going on with this graph. But on an exam, you wouldn't do any of this. And you might not even do this. And if you didn't do this, that would be a bad idea. I think you should, during the exam, if you have a question like this, it would be crazy not to at least do that reduction. Now it looks like what I would expect your paper to look like.